Hello, these are the exercises for section 6.5, Inference for Linear Regression. Are track and field events a good representation of sports at the Olympic Games? The data below are the number of medals won in track and field events and the total number of medals won in the 2016 Rio Summer Olympics for a random sample of 8 medal-winning countries. So the first thing we have to do is make sure that we have met the conditions for the regression analysis. The first condition is linearity. Okay, and this is looking at the scatter plot and seeing that there is a linear trend present. So that is satisfied. And the next criteria is that we have to have independent observations. This is this is satisfied due to the fact that this is not a time series. And this data point for Canada here is not going to influence the data points for Dominican Republic, for example. Okay. Next, we have to have an approximately normal residuals. Okay. This is satisfied by looking at the histogram of the residuals, and you can see that it's somewhat bell-shaped. Okay, and so therefore it is approximately normal. And the last criteria is that we have constant variability. Okay, to satisfy, make sure that this condition is satisfied, you look at the residual plot and you look at these points, and there's no obvious trend of the residuals. There is not a curve. They're not getting consistently larger or consistently shorter, smaller distance away from this line, etc. So there's consistent variability between there. Okay. And we will see the scatter plot and the residual plot in a little bit more detail in a moment. So we want to go through and you want to find the equation of the estimated regression line. To do this, we're going to go to GeoGebra. I'm going to copy and paste these data points. Be sure to notice that the track and field medals are your X. These are your explanatory variables. And we're seeing if that maybe can be a good model for this Y, the total medals. So this is the response variable. So we're going to highlight these points and go to GeoGebra and paste them in. You want to highlight them and go to do variable regression analysis, and you can see this scatter plot. This is the same scatter plot that you saw on the lecture notes a moment ago. Okay. If you don't see the line, you can come down here, and at the bottom of this, it has this little drop down for the regression model, and you can go and choose linear. Okay, if it's not highlighted with the red line already, so you might have had this initially. So you come and highlight linear, and you get this regression line, and it gives you the equation of this regression line down here. So that is what we're going to copy into our lecture notes. So we're going to have y hat. Y hat indicates our predicted value, and I'm going to just round these to the 2 decimal spots. So I have 3.09x plus 15.75. I know that I said that you could see the residual plot more closely too. If you come down here and on your GeoGebra, click residual plot, you'll get the residual plot that you can check there also. Okay, just for an FYI. So we have our regression model equation, and then the next question that asks us to do is interpret the slope and intercept. So again, The slope is this coefficient in front of the x. So I have 3.09 over 1. So this is for the slope. And I go through and I remember that the slope is the rise over the run, and I go and I attach the units to these different numbers. So the rise is the up and down. So that's going to be the y. So the units for the y is total metals. Okay. And then the units for the x, that's my run, because run goes left and right, is the track and field. Metals. Okay. Then we go through and make this ratio here, this slope, into a sentence. So it says, as we increase, and again I choose increase because that's a positive, as we increase one track metal, track and field metal. Again, you're going to look at the run here. So as we increase one track and field metal, we expect to, and again, this is another plus, so you're going to increase it again. So we expect to increase 3.09 total metals on average. That's how you would interpret the slope. To interpret the intercept, again, you want to make sure that it is appropriate to check the intercept. Okay. The intercept in general is the y value when your x equals 0. And this is appropriate if x equals 0 is reasonable, and these both have to be satisfied to be appropriate, and x equals 0 is within scope of the model. Okay. So x equaling 0, what does that mean in context here? So your x variable, remember, coming back up to your table, your x was the number of track and field metals. So getting 0 track and field metals is reasonable. Okay. Then you want to see if there is any data value that is close to having x equals 0. That's what it means to be within the scope of the model. So we come up to our data table again, and you can see that there's actually a 0 in our data set that we have for track and field for the Dominican Republic. And even if we didn't have that, we'd have ones that have 1 and 2, pretty close to x equaling 0. So that would indicate that we are within the scope of the model. So now with that, let's interpret this. So this is the y value. So the y value is the total metals when x equals 0. So when a track and field metals is 0, should be expected to be, in this one, this is the y-intercept, 15.75, again, on average. Okay, and that would be the interpretation there. And so, let's see, maybe I can get a little bit better picture here. Okay. Good. Okay, so let's go through and look at what is the correlation. So you can find the correlation. That's your R. Or looking at GeoGebra. So we come look at GeoGebra here, and we have the R is 17.2. mean 0.7841, sorry. So my R here is 0.784, I think I said 1. Okay. So this is positive, so it's going to indicate a positive relationship. Okay. And because it's pretty close to 1, it's strong, or at least moderately strong. Positive linear relationship. That's what that's going to indicate. So to indicate if this linear relationship is significant or not, we're going to go through and look at the inference on the slope. Okay, so we have to come into our GeoGebra again, but the GeoGebra little applet that's in Canvas, and we get to highlight. I repeated this data value too many times to make sure that since you have 8 data values in your original data set, you can see here, we had the last data set was 32,121. You want to make sure that when you come in here, that the data values don't start repeating. Okay, and then this should correspond to what you had here. Like there's the slope, there's the y-intercept, and that should correspond to what you did before in the GeoGebra. Similar, you have your R, and that should correspond to what we did earlier too. So we have this t-stat and we have the p-value, and that's what we are interested in here. So my t-stat was 3. My test statistic t was 3.09. My p-value was 0.0213 to 4 decimal spots. Let's just check quick again. Yeah, so you can see here, it's 0.0213 rounded to 4 decimal spots. And that is your p-value. You want to compare your p-value to your alpha. P-value is less than alpha, and so that results in a significant linear relationship. So we're going to predict the total number of snow medals for a country that wins 20 track and field. Snow medals, number of total medals for a country that wins 20 track and field medals. So we come and do our regression line. That y hat number is your predicted value, and we have it as 3.09. So we're gonna go equal 3.09 times x. X is the number of track and field medals. So we're gonna times it by 20, and then add 15.75. Okay, and you calculate this out, and you get 77.55. So this is about 78 medals. Okay. As an FYI, if you come back to your GeoGebra, you can get a non-rounded version of the answer by plugging in 20 here, and you can get a very close what we just got. They are just using like 10 decimal spots to doing that, so they have a little bit different accuracy and precision. Okay, and that helps you to verify your answer. Okay, so we're going to compute the residual for the Czech Republic. So the Czech Republic had 1 track and field metal. So to find the residual, remember, the residual is observed minus the predicted. This is y minus y hat. So we know what the observed is. The observed is what is we actually have in our table here, which is when we had 1 track and field, we got 10 total medals. So we're going to have our y is going to be 10. But we need to find the predicted. And you find the predict by finding it from the regression line. So you're going to have 3.09 times 1 plus 15.75. I chose 1 here because on our table, the Czech Republic had 1 track and field medal. So I want to see what would be the predicted total medals if that was the case. And I have, I'm going to do that, 18.84. Okay, so I'm going to have 10 minus 18.84, which is a negative 8.84 medals. That is my residual. Since it's a negative, that means that the observed is below the predicted. Observed value is below predicted. Okay. And lastly, we are asked to interpret r squared. So you can find r squared in a couple of different places. You can see it on the standard GeoGebra. You can see r squared right here, the 0.6148. Similarly, when you look at in your Canvas version of it, you have your r squared there also. Okay, so I'm going to do it to 3 decimal spots. So we have my r squared equals 0.615. And this is interpreted as saying that 61.5% of the variation in the total medals is explained by the least squares regression line using track and field medals as the explanatory variable. Okay, this means that it is not a bad model to use the track and field medals to predict the total medals. However, there's a lot of other variation, other features that this model does not take into account, that maybe a different model could be better. Okay, thank you.